Welcome to the first video of Chapter 4. This video covers Section 1, which is Apply Triangle Sum Properties. Chapter 4 is all about triangles, so this first section is just the basics. We have three objectives that we're going to cover. We are going to classify triangles by sides and angles. Sorry, that should be a triangles by sides and angles. We are going to calculate an exterior angle measure using the exterior angle theorem. And then we're also going to calculate interior angle measures. We're going to start off with some definitions and some ways to classify sides. So, here we go. Classifying by sides. A triangle that is scalene has no congruent sides. So in other words, all three sides are different. Different lengths, that is. Isosceles triangle has two congruent sides, and then an equilateral has all three sides are congruent. Okay, so that's any time that you are asked to classify by sides. If you are asked to classify a triangle by sides, one of these terms will apply. You are also going to be asked to classify triangles by angles, in which case there's also a few terms. Acute means that all three angles are acute. A right triangle means that one angle is right. The other two angles are going to be acute. An obtuse triangle has one obtuse angle. And lastly, equiangular means all three angles are congruent. Okay, so we're going to do some examples. Looking at example number 1, we are asked to classify the triangle by sides and angles. So first thing, this is what's called a fractal, this triangle. It's actually known as Sierpinski's triangle. It's actually one of my favorite triangles, so we'll talk about it more in class. But classifying by sides and angles. So in terms of sides, it looks like all three sides are congruent, so this would be an equilateral triangle. In terms of angles, it also looks like the angles are congruent, so this would be an equiangular triangle as well. This actually brings us to a point that you're going to learn later in the chapter, but I'll give you a little bit of a preview. All equilateral triangles are equiangular. Now I told you that Sierpinski's triangle is one of my favorite triangles, so I'm going to show you a quick video that shows you kind of the magic behind Sierpinski's triangle. So I told you that Sierpinski's triangle is one of my favorite triangles. So I'm going to show you a little video that shows you the magic behind this triangle. Okay, so this triangle is called a fractal because anytime you zoom in on the triangle, you still have the original triangle. So you're going to notice here we keep zooming in and zooming in and zooming in and zooming in, and yet we still end up with the same Sierpinski's triangle. So this is what a fractal is called. So it's a little bit mesmerizing. So this is Sierpinski's triangle. There's a whole bunch of other fractals out there, so you can ask me in class if you're interested. Let's move on to the next example. Next example has to do with the Bermuda Triangle. So it tells us a few pieces of information that we're going to want to mark on our figure. The distance from Miami to Bermuda is 1,037 miles. The distance from Bermuda to San Juan is 965. And then the distance from San Juan to Miami is 1,033. Okay, so we need to classify this in terms of sides and angles. In terms of sides, all of my sides are different, so this would be a scalene triangle. In terms of my angles, I don't exactly know what the angles are, but I can guess that they're all acute. So this is an acute scalene triangle. A little bit about a background on the Bermuda Triangle. I'm sure you guys have heard of the Bermuda Triangle. It's this area between Miami, Bermuda, and San Juan, where a ton of ships have disappeared. The triangle covers about 500,000 square miles of ocean. The first time it was really written about was by Columbus. So Christopher Columbus sailed through this area, and he reported a few strange things happening. Then Shakespeare wrote this book, The Tempest, or this play, The Tempest, and some people claim that The Tempest was written about the Bermuda Triangle. One of the most famous ships that has disappeared in this area is the USS Cyclops, which is a 542-foot-long Navy cargo ship, and it disappeared in March of 1918, carrying over 300 crewmen and 10,000 tons of manganese. The ship sank, never sent out any distress signal at all, even though it could, and it was never found. So that was pretty interesting. And then that was the USS Cyclops, and then two of its sister ships sank about 20 years later. So this triangle is very mysterious. So that was classifying. If you want to move on to the next page, please. Okay, so here's your next one. We are going to classify the triangle with the given coordinates. So first thing that we want to do is, of course, draw ourselves a picture. Okay, so my first point is at -2, 2. My second point is at 4, 2. And then I have a point at 1, 6. So in order to classify by sides, I need to know all of my side lengths. So I'm going to label these points A, B, C. Remember, to find the length of the side, you need to use the distance formula. That means we're going to have to use the distance formula 3 times, 1 for each side. So for side AB, I'm going to have -2 minus 4, so subtracting my x's, subtracting my y's, I have 2 minus 2 squared. So remember, distance formula, I have x1 minus x2 squared plus y1 minus y2 squared. Okay, so this becomes the square root of -6 squared plus 0 squared, square root of 36, so AB equals 6. Okay, right now pause the video and you do the next two. Find the length of BC and the length of AC. Good luck. Okay, you should be back. You should have found BC and AC both to be 5. If you didn't, you made a mistake, so go back and fix it. Now, we know that we have sides of 5, 5, and 6. That means that this is an isosceles triangle because it has two sides that are congruent, my side of 5 and my other side of 5. Now, we're not going to classify by angles just yet. We're going to leave that until a later problem in the video. But for this problem, we have an isosceles triangle. Two sides that are congruent, and then a third side that's different. Next, we're going to move on to some more vocabulary. That vocabulary is interior and exterior angles. So if I draw myself a triangle, as you can probably guess, these angles on the inside, these are called interior angles. The exterior are more difficult. The exterior happen when you continue a side. So this would be an exterior angle. If I continue this side, this would be an exterior angle. So what you should notice is that the interior angles and exterior angles are supplementary. So for example, this pair right here, I have one interior in red, one exterior in blue, and then they're going to be supplementary. Okay, so next theorem is called the triangle sum theorem. This one you already know, but this theorem says that the interior angles of a triangle sum to 180 degrees. So that we've already used, you already know that, but we're going to do some examples. So there's 3 examples for this. I'm going to do A with you. So I have 3 interior angles. They're going to sum to 180. So I have 62, add 48, add x equals 180. They're all interior because they're all on the inside of the triangle. If I add 62 and 48, I get 110 plus x equals 180. Subtract 110, subtract 110, I get x equals 70. For right now, we're going to skip B, and you're going to do C. Pause the video and try C on your own, please. Good luck. Okay, so we have interior angles in this case, so they're going to sum to 180. So I have x plus 5 plus 3x plus x equals 180. X, 3x, and x will give me 5x plus 5 equals 180. So you get x equals 35. So hopefully if you got that. If not, hopefully you see what mistake you made. We are going to skip B, but you are welcome to do example B if you would like. If you end up completing example B, you should get x equals 15. Okay, moving on to example 3. I would like you to do this one on your own. Also, pause the video and try this one on your own, please. Come back when you are finished. Okay, let's see how we did. You should have, again, added up those angles and set them equal to 180. This time you have a 90-degree angle thrown in, as you can see by the box. Now, 2x and x will give me 3x. Negative 6 and 90 will give me 84. If I subtract 84, I get 3x equals 96. Dividing by 3, I get x equals 32. Okay. Now this example is going to lead us into our next idea, our next corollary. So let's substitute that 32 into our triangle. 2 times 32 will give me 64, and then 32 minus 6 will give me 26. Okay, so the next corollary says the acute angles of a right triangle are, so if we look at the right triangle above, F is my right angle. Well, what's true about these other 2 angles? You should notice that they are complementary. So in any right triangle, the 2 angles that are not right, those angles are going to be complementary. They're going to sum to 90. Okay, flip the page, please. Okay, we're going to learn another theorem. So this theorem is called the exterior angle theorem. So the exterior angle theorem says that an exterior angle is equal to the sum of the non-adjacent interior angles. So the exterior angle is equal to the sum of the non-adjacent interiors. So to show you what I mean, we're just going to jump in with example A. So my exterior angle here is 130. So 130 equals the sum of the non-adjacent interior angles. Okay, so in this case I have 3 interior angles. One of them is adjacent to the 30, and that's the 50. Adjacent, they're right next to each other. That's not the one I want then. I take the 2 that are non-adjacent and I add them up. So x plus 4x plus 10. The one that's adjacent or right next to the exterior angle, that's the one we don't use. And now solve like normal. X and 4x will give me 5x. So I get 5x plus 10 equals 130. Subtract 10. So I get 120 equals 5x. If I divide by 5, I get x equals 24. Now, I did not read the directions before I started the problem, but the problem does say find the value of x, which we did, and the measures of any unknown angles. So it's now our responsibility to substitute 24 back in. So for angle T, I get 24 degrees. For angle H, I have 4 times 24, which is 96, and I add 10, which is 106 degrees. A good check is to make sure that your interior angles sum to 180. So angle T is 24, angle H is 106, and angle E is 50. Those sum to be 180. Okay, you try B. Pause the video, try it on your own, and come back when you are finished, please. Okay, let's see how we did. Now, our exterior angle in this case is 5x plus 12. So I have 5x plus 12 equals. Out of my interior angles, 43 is the one that's next to the 5x plus 12, so I don't use that. So I'm going to add my 70 and my 67. This leaves 5x plus 12 equals 137. If I subtract 12, I get 5x equals 125. Dividing by 5, I get x equals 25. Now remember that you're not done yet. You have to substitute that back in right here. So 5 times 25 is 125. I add 12, that gives me 137 degrees. So hopefully that one went well for you. If not, hopefully you were able to identify the mistake that you made. Let's move on to example number 4. Okay, this example is optional. If you get the idea, you can move on to example 5. If not, and you want one more practice problem, I'm going to go through this one with you. In this case, 2x minus 5 is my exterior angle. So I have 2x minus 5 equals, this is my interior, which I'm not going to use since it's right next to the 2x minus 5. So I use the 70 and the x. So I get 70 plus x. If I subtract x, and I add 5, and I add 5, I get x equals 75. Now, the problem asks for angle JKL. So the problem asks for this angle right here. So let's substitute that 75 in. Well, I know that angle J is 75 degrees. And then this angle right here, I have 2 times 75, which is 150. Subtract 5 is 145. So we have a few options in terms of finding angle JKL. I'm going to use the fact that the triangle is equal to 180. So I have 75, add 70, add angle JKL equals 180. 70 and 75 gives me 145. So I have 145 plus angle JKL equals 180. If I subtract 45, I get angle JKL is 35 degrees. Okay, so hopefully we now understand the idea of exterior angles. Let's move on to example 5. Everyone right now should be on example 5. So this one says triangle ABC has vertices at 1, 9, 4, 8, and 2, 5. Graph the triangle and classify by its sides, then determine if triangle ABC is right. Okay, so A is 1, 9. Which is here. B is 4, 8. And C is 2, 5. Okay, first, to classify by sides, we already talked about you're going to have to do the distance formula. So for AB, I have 1 minus 4 squared plus 9 minus 8 squared. This becomes negative 3 squared plus 1 squared. So AB is the square root of 10. For BC, I have 4 minus 2 squared, 8 minus 5 squared. This is the square root of 2 squared plus 3 squared. So BC is the square root of 14. Or, I'm sorry, 13. Right now, this tells us we don't have an equilateral triangle. So it could be scalene, it could be isosceles. Can't be equilateral because my sides are not all congruent. And then we have AC to do. If you did the distance formula for AC, you would get a square root of 17. Okay, all sides are different, so this is a scalene triangle. Now, the new part is determining if this is a right triangle. There's a few ways to do this. One uses slope, the other uses Pythagorean theorem. So that's what I'm going to do. Remember Pythagorean theorem from last year is a squared plus b squared equals c squared. Okay, remember that c is our largest side. In this case, our sides are root 10, root 13, and root 17. Root 17 then is going to be my c. That means a and b, sides a and b are root 10 and root 13. Okay, root 10 squared is just 10, root 13 squared is just 13, and root 17 squared is just 17. So I have 10 plus 13 equals 17, so 23 equals 17. Is this true? Well, no, this is not. This tells us that this is not a right triangle. If the Pythagorean theorem works, it's a right triangle. If not, it's not a right triangle. It's okay if that's confusing. If that was unclear, please put down a question mark or star it so that you know to ask me in class tomorrow. And we will do another example in class. Now I know this was long, but we're on the last page, so flip the page one more time, please. Okay, we have reached the end of our time together. We learned about a few different things today. We classified triangles by sides and angles. Sides being scalene, equilateral, or isosceles. Angles were right, acute, obtuse, or equiangular. We calculated the exterior angle measure, which is the example that you're going to do. And then we found interior angle measures using the triangle sum theorem. So the fact that the interior angles sum to 180. This is your objective problem like we always have at the end of every video. Please complete this problem in order to receive credit for this video. If you don't know how to do it, look back in the video notes and look at a similar example. Good luck!